Continuing with Section 8, Part 3, now we will do hypothesis testing about a mean with population standard deviation unknown. Recall we can do the traditional method or the p-value method. Recall that we use the student t distribution when we don't know population standard deviation. An example. Let's start by reading the problem and highlighting key information. We have n equals 81 students, sample mean of 4.8 years, sample standard deviation of 2.2 years, and we want 0.05 significance. Step 1, we identify the null and alternate hypothesis. The claim is in the form of our alternate hypothesis, HA. Population mean is greater than 4.5 years. This means we are doing a right tail test. Step 2, we find the test statistic. Writing the formula for the test statistic with population standard deviation unknown. Now we just use our calculator to evaluate. So our test statistic is 1.227. Step 3, we find the critical value. Let's draw a diagram real quick so it's easier to know if test statistic falls in the critical region or not. So our critical value will have right tail area of 0.05 and degrees of freedom will be 80. Looking on the chart, from the chart we get critical value of 1.664. And we can see that the test statistic does not fall into the critical region. So fail to reject the null hypothesis HO. There is not sufficient evidence to support claim that mean time for college students is 4.5 years. Next example. Highlighting key information. We will use the p-value method this time. N equals 100 credit card charges, sample mean being 47.6 cents, sample standard deviation of 33.4 cents with a 0.05 significance. Step 1, labeling null and alternate hypothesis. Claim is about the null hypothesis, H sub 0. So alternate hypothesis is population mean not equal to 49.5 cents. Which means we're doing a two-tailed test. Step 2, we find the test statistic. Writing the formula for the test statistic real quick. Now we plug in our known information and evaluate using our calculator. pretend Jeopardy music is playing. And we get negative 0.569 as our test statistic. Step 3, now we find the p-value. So we use the TCDF function on our calculator, since we are using the student t distribution. Since it is a two-tailed test, we need to multiply by 2. Entering it in our calculator, we do it in the form of TCDF lower, upper degrees of freedom. Remember to get there on the calculator, we hit second, then vars. And we need to multiply this by 2 since it is a two-tailed test. And we get p-value of 0.571, which is greater than our level of significance of 0.05. Step 4, we fail to reject the null hypothesis. There is not sufficient sample evidence to support the claim that the sample is from a population with a mean equal to 49.5 cents. Next, we will be testing a claim about variance or standard deviation. Listed here are the requirements as well as the formula for the test statistic. Step 1, we label the null and alternate hypothesis, ho and ha. In this example, the claim is about the alternate hypothesis. Which ends up being a right-tailed test. Now let's label some key information real quick, like sample size and degrees of freedom. Step 2, we find the test statistic. So write the formula down for that. Since we have the data, we need to find the sample standard deviation. So we enter the information on our calculator in the list section. Whoops, need to clear all this data real quick. Now we just enter in the data. Then use the 1-bar stats function in our calculator. We can see the sample standard deviation is 11.2, so we square that number to get the sample variance. And we get sample variance of 125.5, rounding to 1 decimal. Now we enter our information into the test statistic formula. We get 27.453 as our test statistic. Now we find the critical value. So we need the level of significance, the degrees of freedom, and the fact that it is a right-tailed test. Looking on the table for it now. And we get 21.064. And that is in the critical region, so we can reject the null hypothesis. The sample data support claim that the standard deviation of the number of people using outpatient surgery is greater than 8. Next example. Let's label some key information. Sample of 25, sample standard deviation, and level of significance. Step 1, write the null and alternate hypotheses. This example, the claim is about the alternate hypothesis. This will also be a two-tailed test. Step 2, we find the test statistic. Writing the test statistic formula down. Now we just plug in our information and evaluate. And we end up with 32.086 as our test statistic. Now we evaluate the p-value. We do need to know the degrees of freedom and level of significance here. Evaluating the p-value, we use the chi-squared CDF function on our calculator. And since it is a two-tailed test, we multiply it by 2. To get the chi-squared CDF function on the calculator, we hit second, then bars, and scroll to it and hit enter. Then enter our lower, upper value, then degrees of freedom. Rounding to 3 decimals, we get p-value of 0.250. And this is greater than our level of significance, 0.05. So we fail to reject the null hypothesis, HO. There is not sufficient sample evidence to support the claim that 100mm cigarettes have standard deviation different from 3.2 mgs.